To calculate the size of the page table, we know that a page table has number of entries that is equal to the number of virtual page numbers that exist in a virtual address space. For every one of these entries, we know that the page table needs to hold the physical frame number as well as some other information like the permission bits. Here's something that would make sense on a 32-bit architecture. So each of the page table entries is 4 bytes, and that includes the page frame number as well as the flags. The total number of page table entries, that will depend on the total number of VPNs. And how many VPNs we can have, that's going to depend on the size of the addresses, of the virtual addresses, and of the page size itself. So let's say in this example, we have a 32-bit both physical memory as well as 32-bit virtual addresses. So that will be 2 to the 32nd, and that will have to be divided by the actual page size. Different hardware platforms support different page sizes, but let's say we pick a common 4 kilobyte page size for this example. In that case, if you do the math, you will see that the page table will be 4 megabytes, and it will be 4 megabytes for every single process. With many active processes in an operating system today, this can get to be quite large. If we try to work through the same kind of example for a 64-bit architecture that, say, has a page table entry size of 8 bytes, and let's say we use also the same 4 kilobyte page size, we come up with a really scary number of 32 petabytes per process. So where does one store all of this? Before we answer that question, it's important to know that a process likely will not use all of the theoretically available virtual memory. Even on 32-bit architectures, not all of the 4 gigabytes of virtual address space is used by every single type of process. The problem is that the page table, as we described it so far, it assumes that there is an entry for every single VPN. And that is regardless of whether the corresponding virtual memory region is needed by the process or not. So this page table design really explodes the requirements of the page table size. And what we'll do next, we'll look at some alternatives of how to represent a page table.